Polynomial functions. Here's a very simple function to sketch. But so many times I've found students incorrectly sketching the graph of this polynomial function. I've taken this example so that I can point out what mistake they have been doing so that it is not repeated anymore. I hope they pay attention to this video and understand what I'm trying to say. Okay, let's read the question. Consider y equals to minus 2 x plus 3 whole square times 4 minus 2x cube. Find y-intercept, explain the zeros, what should be the fifth finite difference, explain the end behavior, and sketch the function. Okay, I'd like you to sketch the function and answer these questions on your own. Stop the video for the time being. Once you're done, then look into the solution, right? Okay, now here is the first part, which is A, which says y-intercept. So that's simple. What is y-intercept? So y-intercept means that x equals to 0, right? That is a place where your graph will cut y-axis. So we can say y-intercept is f of 0, correct? So let me use the convention. F of 0 equals to, we'll plug 0 for x and find our answer. This is minus 2 and 0. Let me write 0 first. 0 plus 3 whole square, and this is 4 minus 2 times 0 will be 0 cube, right? And therefore we get minus 2, 3 square is 9, and 4 cube is 4 times 4, 16 times 4, 64, right? And this is equals to negative of some big number, and that number is 2 times 9 times 64, 1152. So that number is 1152. So the first part is done for us, and that is the y-intercept. Correct. Now second is explain the zeros. So let's do zeros now. So part B is zeros. So we can see there are two kinds of zeros here, right? Because there are two factors which could be 0. So either x plus 3 equals to 0, that implies that x equals to minus 3. Now here this factor is to the power of 2, right? So the order of the 0 is, order is 2, right? Because this is basically x plus 3 square, right? That's why. So that's first 0. The second one is 4 minus 2x, and that is equal to 0, implies that x is equals to 2, right? And the order for this is 3. Why? Because this is in the factored form of cube. So these are my two zeros with their order. Order really means that here this will turn back and here this will go like this, right? That's the nature at x-intercept for these zeros, right? This will bounce back and this will think and then go. So that is the nature of these zeros, and that is what you can explain also. Now the third question is, what should be the fifth finite difference? This is where many students get it wrong, and here onwards, right? Now why do they get the mistake? Now let me give you what is finite difference. Finite difference is actually related with your leading coefficient, right? So for example, if your the leading coefficient is, let me write down the formula for you, as that is going to help you. Now we say C, finite difference and leading coefficient are related as constant finite difference is equal to leading coefficient times, let's say leading coefficient of n, finite difference of n, where n is the degree of the polynomial, right, times n factorial. So that is the relation between them, correct? Now if we have a correct value of an, now here we know n is 5 because the degree of the polynomial is 3 plus 2, 5. So we can put 5 here. So fifth finite difference is a constant difference, and the leading coefficient is this number, and n is 5 factorial. That means 5 times, 4 times, 3 times, 2 times 1. But that is a mistake where many students will do. Now I'll show you how to not do the mistake. If you write minus 2 here, you're going to get a wrong answer. Why? Because the leading coefficient is not minus 2. What is it then? Let's calculate. So let's calculate the leading coefficient here. So I'll kind of expand this, but not fully, right? I'm interested only in the x coefficients. I need to multiply all the x's and see what highest value I get outside. So all I'll do is I will factor this out. So I get minus 2 times x plus 3 whole square. So here if we expand it, we get x square plus 2 times this, which is 6x plus 9. But see, the coefficient of x square will be 1 only. So 2 times 1 will be 2 only, right? So here it doesn't matter, but here it matters a lot. Now let me do this part. I'll put a square bracket and I'll try to factor out minus 2 from here. So if I do that, so I get minus 2 factored out, I get x minus 2 whole cube. Do you see that? The reason is I want to take out this 2, right? And then see, I'll show you what I'm trying to do. So we get x plus 3 whole square and minus 2 cube, and this could be written as minus 2 cube, right? It is minus 2 cube times x minus 2 cube. Is it okay? That is how it is. And minus 2 cube is minus 8. Minus 8 times minus 2 is plus 16. So the leading coefficient becomes 16 for us. And I'll write the other terms, x minus 2 cube. Do you see, our zeros are same. Zeros are at x equals to minus 3 of order 2 and at x equals to 2 of order 3, correct? Y-intercept will be same because if I plug in 0 here, I get 16 times 3 times 2 cube minus, right? Which I have here, a negative answer, perfect. So I saved myself from doing a big mistake. A is 16, not minus 2. That is what I was trying to get to. Now here, I can always write A as 16, and then n factorial is 5 times 4 times 3 times 2 times 1, and then I know what it is. I need a calculator to calculate, okay? So it is 16 times 5 times 4 times 3 times 2 times 1, 1920. So it is 1920 for us. So that is the leading coefficient, 1920, okay? Now let's move on to part D. Explain the end behavior. Now end behavior also we are going to get right now. We are not looking at minus 2, we are looking at 16, okay? So and the next part is sketch a graph. So let me make a big graph here. That'll be good. Now, here in the graph, as you can see, we are considering this equation, right? Leading coefficient is positive. That means right side is up. So my nature of the graph is like this. And the degree is, oh, forgot to write 2 here, okay? 2, right? Here it is 2. Correct. So the degree is 5, 3 plus 2, 5, odd degree, opposite end. So that is my end behavior. So let me fill in the end behavior first. So we say when x approaches minus infinity, then y approaches minus infinity, right? And if x approaches positive infinity, this side, in that case, y approaches positive infinity, that side. Do you see that? That's kind of our end behavior. And now let's get back to part E, which is sketching the graph. So let's sketch the graph now. Now, to sketch the graph, let's point out this zeros. So zeros are at minus 3 of squares. So we have minus 3 here, and then 2, which is cubic. Let's say cubic is here. Now if you are sketching a graph, it is moving from quadrant 3 to 1. So at minus 3 we have order 2, so it's going to turn from it. Do you see that? It's not going to cross, and here it will cross like a tilde, right? It kind of bends and goes away, right? Thinks and goes. And now we can join these points and make a graph out of it. That is our function. It goes like this and here, kind of. Do you see? So that is your graph. And you can always say this is my y-intercept and the value is minus 1152. Imagine if you would have used minus 2, your graph would have been upside down and you would have never got minus 1152 as your y-intercept. So that was a check for you. So if you don't get correlation, then check your result. Okay? I hope you understand and appreciate the way I've done it, and don't make the mistake of not factoring out this number, coefficient of x, from here, and because that affects your leading coefficient and makes things very different. Okay? I hope you understand it. Thank you.